Dear friends, welcome to Infos. Welcome to Oil and Gas Training Series. This is our valves video continuing, valves part number 9. In this video, we are discussing about mainly manual operators and actuators. So, the driver of the valves. In our earlier 8 videos, we have discussed valve closure element and operation system, type of valve, behavior, characteristics, etc. etc. Different type of valves. So in this valve, the driver of the valve, how we are energy giving energy to change the valve position or opening or closing. So it is mechanical manual persons operator, those who are giving energy, or another type of energy system called actuator. So in this video we are discussing some part of some information of manual operators and actuators. Definitely it is more, maybe 2-3 videos are there. So let us see how it is going on. Welcome to this video, manual operators and actuators. With most valves, some mechanical device or external system must be devised to open or close the valve or to change the position of the valve if it is to be used in throttling services. So, some mechanical device or external system is required. Look at that one. This is type of actuator. An example: manual operators, actuator and actuation system are those mechanisms that are installed on valves to allow this action to take place. A manual operator is any device that requires the presence of a human being to provide the energy to operate the valve as well as to determine the proper action, either open, close or throttling position. You can see here that one, this is the hand wheel is there. So the operator can operate up and down or sideways to close or throttling or open the valves. Manual operators require some type of mechanical device that allow the human being to easily transfer muscle strength to mechanical force inside the valve, usually through a hand wheel or a lever that provides mechanical leverage. These are two examples of manual operation system. So operator can work on it. Some gear mechanism also giving inside to make that the mechanical energy can transfer easily and for easy operation of the valve. Although over the past three decades, their use has declined somewhat in favor of automatic control actuators. So manual operation system is reducing and adding a mechanical or other type of actuators with automatic control system is implementing in valve opening and closing technology or external power technology. The reason is simply the cost as well as imperfections of human operator. Simple, the operator can go and do the job from the field. Perfection is important, and cost is there, operation difficulty for operation, and safety also, efficiency also. So that way the replacement is slowly taking place. Nearly all plants today are looking for technology to replace human beings, not only because of the human resource cost but also greater accuracy, efficiency and productivity associated with higher technology. Simply, greater accuracy, efficiency, productivity. This is why slowly industries are changing to actuator using technology for valve operation. Definition of actuators and actuation system. You can see that when the picture is the typical example or picture of a control valve. This is the flow area, closure element, the pipe is connecting, and this is the position indication, and this area we can call simply actuation system here. Here the diaphragm is there inside. Details we are giving in coming slides. Automatic control of valve require an actuator which is defined as any device mounted on a valve that in response to a signal automatically moves the valve to the required position using an outside power source. So this actuator is receiving the signal from controller. If you remember that one, or if you have watched my instrumentation control system, so all control loop instruments we are discussing on that one. So in that one, from where the signal is coming, so control valve is receiving signal from the controller. So here it is that it is in response to a signal automatically moves the valve required position using an outside power source. Addition of an actuator to a throttling valve which has ability to adjust to the signal called a control valve. So this is a control valve. Actuators can call to a power actuated operator using an outside signal and power source rather than a human being. Like this is the actuator. It is connecting a outside power source. Typical classification of actuators include pneumatic actuators, diaphragm, piston, cylinder, vane, etc., or electronic motor actuators and electro-hydraulic actuator. So usual different classification, that one pneumatic actuator using compressed air. In that one, the type of here, this is the actuator system, this is the valve system. So diaphragm, piston, cylinder and vane. Some of them we are studying in detail. The actuation system, what are the different type of diaphragm and piston type actuation system, we will go through in design and operation in detail. Actuation systems are special actuators that are commonly mounted on manually operated valve and can be used in either on-off or throttling application. So actuation system can work both on-off. On-off means like shutdown valves. Throttling valve is of course control valves. So both the case actuation system can work. Actuators are critical elements in a control loop which consists of a sensing device, controller and an actuator mounted on a valve. Here the pipeline is there. You can see here, see the flow meter is here and flow transmitter is there. That is what is telling sensing device, controller and actuator mounted. So here the sensing device is there and of course a transmitter is there. There is a controller is there. Controller output is going to control valve, but here it is a transducer is there. That is a auxiliary equipment instrument using for converting electronic signal to pneumatic signal. That's why this is here I2P converter. Transducer or I2P converter is there and the pneumatic signal controller is giving electronic signal and here the pneumatic signal is receiving to the actuator. So the power source is air, compressed air is the power source that is connected to actuator system of the valve. This is the valve. So here the actuator. So valve is opening and closing according to the flow increasing and decreasing. So that is what is discussing here. Actuators are critical elements in control loop. So this is a control loop. This is a control loop which consists a sensing device, controller and an actuator mounted on a valve. Other equipments are there inside. Positioner is there that we are studying in later, but at least the controller output is going directly to actuator system of the valve to giving the signal of communication to the actuator for the opening and closing the valve either directly or through a transducer or I2P converter. With a control loop, a sensing device in the process system such as a temperature sensor or a flow meter. This is a sensor we are using. Any type of sensor, flow, level or pressure and temperature. Installed downstream of the control valve and is set to measure a particular variable in the process. Here the downstream or upstream, both way we can work it on that one. So here it is downstream of course after the pump. This is the flow meter. The sensor reporting its finding to a controller. Very simple. Sensor reading is going to controller, but through a transmitter, because transmitter receiving signal from sensor and converting into suitable signal. Here it is a electronic signal, 4 to 20 milliamp signal to the controller. Controller is located in a centrally located control room, either local control room or DCS control room or SCADA control room. Any control room it can provided. And controller receiving the signal, then compare with the set point, then the output is providing to the actuator system through converter. This control system, basic control instrumentation and control system, I have explained in detail almost 5 to 6 videos in my process instrumentation control area. If you didn't watch that videos, please I request please have a look that one. It is good videos on basic instrumentation and control. So that the sensor reports its finding to a controller, which compare the actual data, that is actually with the set point, against the predetermined value required for the process. If the measured value is different from the predetermined value, the controller send a correction signal to control valve actuator. That is what is happening here. This signal can be sent using one of 3 methods: increasing or decreasing air pressure, varying electric voltage, or increasing or decreasing hydraulic pressure. So this 3 method we can send the signal. We will discuss that one. The actuator receives this signal and moves accordingly to vary the position of the closure element until the controller determines the measured value is equal to predetermined value. The actuator receives the signal and moves accordingly to vary the position of the closure element. This is what actuator is doing. Actuator is moving the closure element up and down until controller determined the measured value equal to predetermined value. That is, predetermined value is a set point. So the measured value is equal to set point, then it will send a 0 output, so no change in the actuator. If or positive change or negative change, controller will send a signal accordingly and actuator will receive the signal and take its action accordingly to increase or decrease the fluid flow in through the valve. At that point, the signal increase or decrease stop, and the actuator and subsequently the closure element hold its position. So this is a controller and actuator is showing in another way, and the position also showing positioner we will discuss in detail in our coming videos. The majority of application requires actuators today require the use of a compressed air, with 9 out of 10 actuators are pneumatically driven. So that is pneumatic actuator means it is using compressed air. We provide compressed air from outside to the actuator system separately, and from the if the electronic controller is there, that will produce a electronic output that will go to transducer, and a transducer also we will provide a separate compressed air input, and the proportionate signal output in terms of in the form of air signal, it is receiving to the positioner, then it is going to the actuator. But actually we are not discussing positioner today. After the from the I2P converter, it is coming to positioner. Actually from the positioner it is going to actuator system. So we are discussing only actuator system. So the instrument air is the common application. The actuator today, compressed air is using for the actuation system. Most of the cases, that is what is discussing here. Air is by far the preferred power medium, since it is relatively cheap and is available in nearly all plants. So these reasons are the many reasons are there. Some of the reasons we have added here. So it is cheap, environmentally free, easily available. Typical plant compressed air supply is generally between 60 to 150 psi, between 4 to 10 bar. almost compressed air. We are using instrument compressor, which is sufficient to run a large portion of pneumatic actuators available today. So these are the instrumentation system will be there, instrument air system. Other power sources can include electrical, both AC and DC, as well as hydraulics, to a far lesser extent steam. So hydraulic system and electrical system, we can use that one. In wellhead, most of the cases wellhead actuation system will be hydraulic, not air system, normally not using. So electrical, many MOV, motor operator valves are there in the field. MOVs are there. If you are looking at P&ID, sometime it is written MOV, motor operator valve. So many are there. So that system also we can use. But in the common, mainly majority of the use is instrument, compressed instrument air as a power source. Although electromechanical and electrohydraulic actuators are more expensive than pneumatic actuators, they do have advantages of extremely good accuracy and the ability to operate in environment experiencing low temperature. So this is expensive, but they have their own accuracy and advantages are there, where typical airlines can freeze from condensed water when high thrust are required. So some locations, some requirements are there, specific areas we have to use electrical and hydraulic system, power sources we have to use. Actuators are described as either single or double acting. So type of actuators are coming next video, next session. A single acting actuator using a design in which a power source is applied only one side here. See, single acting, only power source is applied here. The one side it is using and other side is a spring connected of an actuator barrier, piston or diaphragm or vane, etc. And the opposite side not opposite to power sources. So one side power acting, other side is equalizing system. A spring may be added to the opposite side to counteract a single action. See, this is the method of single, and the double actions are there, reverse action is there, many type of actuator is there. I am not going to in detail that one, but generally whatever the information available, let us see. A related term is the direct acting actuator. Here that one, direct acting, the air is entering from the top, which refers the design in which power source is applied extend to the stem. It is pushing the stem down. And a double acting actuator is term used for actuator that have power supplied both side of an actuator. So single acting and double acting is there. Single acting power source is in one side, double acting power source is in both side, and direct acting and reverse acting. When the power is giving to the top or power is giving the same direction, the stem is moving, is direct acting, and the reverse acting is it is opposite side. The air is giving opposite side and it is lifting the stem and spring system to the up. So this is the source is applied to extend the stem, like this one, extend. And on the other hand, a reverse acting actuator refers to an actuator where the power source causes actuator stem to retract, here moving. So here the actuator air is supplying, actuator is pushing down, and here it is air, it is in and it is lifting up the stem up. So this is the direct acting and this is the reverse acting actuator. So single acting and double acting actuator, direct acting and reverse acting actuator. So many type of, according to the, mainly it is for the safety purpose, fail to open, because if the power source is not available, the valve has to go its safe mode, fail open. It is written air fail safe or air fail open in that method. So to prevent the plant or to keep the plant in a safe condition for that shutdown purpose and many other application, this actuation system is single acting, double acting or direct acting or reverse acting. An actuator is normally a separated sub-assembly from the body. Here it is a sub-assembly from the body. This is the body, this is the positioner area and part of actuator system. This is the real actuator, meaning it can be moved from the body for servicing without assembly of the body as sub-assembly. without the disassembly of the body subassembly. So from the body we can remove this all item separately for without affecting or without disassembled here. On the other hand, the body can be serviced without disassembly the actuator. That is, body can also service without disassemble this actuator system. Generally, manual operators are associated with the operation of on-off application as well as simple throttling application, not require under accuracy or immediate. Coming to manual operation, it is using for on-off application mainly isolation. Still we are using in the field. Simple throttling also we can use, do not require undue accuracy or immediate feedback. Advantage of a manual operator lies in its mechanical simplicity, minimal in moving parts and no sealed chambers to leak or fail. A human being moves one part such as a hand wheel or lever and the valve is opened, closed or placed in a mid-stroke position. This is simple that one, how the manual operation system is working. Design simplicity also means troubleshooting, maintenance, disassembly are easier. The disadvantage of manual operator is slow response. Since the response depends upon a human being operating the manual operator, which in some cases may take some time. So this is the main reason, and efficiency, low efficiency, safety reasons, manpower, cost, many reasons are there in the beginning we have discussed. Generally, manual operators are divided into two categories, linear motion and rotary motion. If you remember type of valve, we have studied a linear motion valve. Stem is moving up and down, vertical movement, and rotary motion is horizontal movement. So this type of two operations are there. Just to have a quick understanding on that one, let us see. Linear operation, manual hand wheels. Here it is their manual hand wheels and stem is moving up and down. Use a threaded connection between a fixed position of the part of the hand wheel assembly such as a yoke or housing and a dynamic part, usually a hand wheel. So you can see everything is there. It is this is moving up and down when the hand wheel is turning left to right or right to left, and clockwise or anti-clockwise, stem is moving up and down and for closing and opening the valve. So linear motion valve. Multiple turns of hand-held part mechanism. In most cases, a hand wheel causes linear movement of the dynamic stem, which is connected to a linear motion closure element. Rotary motion, on the other hand, look at that one. It is manual operators are used in quarter turn. That is very important. Quarter turn horizontally, such as plug, ball, butterfly valves. The most efficient method to turn a quarter turn closure element is through a right angle extension of the stem, which allows a better leverage. You can see here it is like a pressing and moving. So this is also there. So rotary and linear motion valve. Pneumatic actuators are most commonly applied actuator is the pneumatically driven actuator, because the power source compressed air is power source is compressed air relatively inexpensive when compared to human resource or electrical hydraulic power sources. So already we discussed that one, the advantage of pneumatic compressed air as a pneumatic power source. When compared to the cost of electrochemical and hydraulic actuators, pneumatic actuators are relatively inexpensive as well as easy to understand to maintain. So advantage of pneumatic actuators, most common using. From a maintenance standpoint, pneumatic actuators are more easily serviced and calibrated than other type of actuator. That is also one good part which is using that pneumatic actuators more commonly. When pneumatic positioners are used with pneumatic actuators, I told you that the positioners we have to study separately. So positioners are used to pneumatic actuator. They are ideal for use in explosive and flammable environment, since they do not depend upon electrical signal or power, which could potentially spark a fire if not explosion proof or intrinsically safe. So that is also another advantage. Pneumatic actuator design, one key information we can pass here, and more information we can discuss on the other next video, because it's a large area we have to cover. The most commonly applied pneumatic actuator over the past 40 years has been diaphragm actuator. That is important. Most diaphragm actuators are designed for linear motion, although some rotary motion design exists. By definition, a typical diaphragm actuator is a single acting actuator that provides air pressure to one side of an elastomeric barrier called the diaphragm to extend or retract the actuator stem, which is connected to the closure element. The diaphragm is sandwiched between upper and lower casings, either of which can be used to hold air pressure depending on the style of the actuator. So next videos are the more on diaphragm actuator. This is the actuation system, and diaphragm is inside and the positioner is air valve body is here. This we are going to discuss in how pneumatic valve actuators are work. Vane actuator is there, piston actuator is there. This diaphragm and piston actuator more commonly using in many applications are there. So we are discussing on that one. So next video will discuss on pneumatic actuators design and constructional details and other systems and operation of this actuation system, and how it is receiving the signal and how it is providing the signal to valve body on safe and efficient operation of the valves. Thanks for watching this video. Have a good day.